Hello, everybody. Welcome to this month's talk about the immune system. Before we talk about nutrition and lifestyle and how it affects the immune system, I would like to briefly explain a little bit on how it works. This way you can understand how everything is impacted. And just as a disclaimer, all information presented and written within this video is intended for informational purposes only. You should not rely on this information as a substitute for, nor does it replace, professional medical advice, diagnosis, or treatment. If you have any concerns or questions about your health, you should always consult with a physician or other health professionals. What is the immune system and how does it work? The task of the immune system to fight disease-causing germs and pathogens like bacteria, viruses, parasites, or fungi, and to remove them from the body, to recognize and neutralize harmful substances from the environment, and to fight disease-causing changes in the body, such as cancer cells. A complex network of cells, tissues, organs, and the substances they make that help the body fight infections and other diseases. The immune system includes white blood cells and organs and tissues of the lymph system, such as the thymus, spleen, tonsils, lymph nodes, lymph vessels, and bone marrow. The immune system fights germs and foreign substances on the skin, in the tissues of the body, and the bodily fluids such as blood. The immune system is made up of two parts, the innate immune system and the adaptive immune system. The two systems work closely together to take on different tasks. The innate immune system is the body's first line of defense against germs entering the body. It responds in the same way to all germs and foreign substances, which is why it is sometimes referred to as the nonspecific immune system. It acts very quickly. For instance, it makes sure that bacteria that have entered through the skin through the small wound are detected and destroyed on the spot within a few hours. The innate immune system has only limited power to stop the germs from spreading throughout. The innate immune system consists of protection offered by the skin and mucous membranes, and protection offered by the immune system cells, defense cells, and proteins. Please remember the word protein when we discuss how to boost your immune system a little bit later on. The adaptive immune system takes over the innate immune system if it is not able to destroy the germs. It specifically targets the type of germ that is causing the infection. But to do that, first it needs to identify the germ. This means that it is slower to respond than the innate immune system, but when it does, it is more accurate. It also has the advantage of being able to remember the germs, so the next time the known germ is encountered, the adaptive immune system can respond faster. This memory is also the reason why there's some illnesses you can get once in your life, because afterward your body becomes immune. It may take a few days for the adaptive immune system to respond the first time it comes into contact with a germ, but the next time the body can react immediately. The second infection is usually not even noticed, or it might be a little bit milder. The main components of the immune system. The immune system is made up of special organs, cells, and chemicals that fight infection and microbes. The main parts of the immune system are the white blood cells, antibodies, the complement system, the lymphatic system, the spleen, the thymus, and most importantly, bone marrow. Keep in mind this is a basic overview, and the complete immune system is extremely complex. White blood cells. The job of the white blood cell, also called leukocytes, is to fight infection and cancer. They remove poison, waste, and damaged cells from the body. The number of white blood cells increases when a person is fighting infection or disease and decreases when a person is healthy. Antibodies are the large Y-shaped proteins that can stick to the surface of a bacteria or virus. They are found in the blood or other bodily fluids. Each antibody is different. They all are designed to attack only one kind of antigen. The main function of the complement protein is to aid in the destruction of pathogens by piercing their outer membranes or by making them more attractive to the cells, such as macrophages. Macrophages are large, specialized cells that recognize, engulf, and destroy foreign target cells. The lymphatic system is a network of tissues and organs that help rid the body of toxins, wastes, and other unwanted materials. The primary function of the lymphatic system is to transport lymph, a fluid containing infection-fighting white blood cells, throughout the body. This also includes protecting your body from illness-causing invaders, maintaining fluid levels, absorbing digestive tract fats, and removing cellular waste. The spleen is a part of the body's lymphatic system. The lymphatic system helps remove cellular waste, maintain fluid balance, and make an active infection-fighting white blood cells for the immune system. It's also responsible for making substances that play an important role in inflammation and healing. Within the thymus cells, lymphocytes, or T cells mature. T cells are critical to the adaptive immune system, where the body adapts specifically to foreign invaders. T cells are one of the major components of the adaptive immune system. Their role includes directly killing infected host cells, activating other immune cells, producing cytokines, and regulating the immune response. The bone marrow is extremely important to the immune system because all the body's blood cells, including T and B lymphocytes, originate in the bone marrow. B lymphocytes remain in the marrow to mature, while T lymphocytes travel to the thymus to mature. B cells are a type of white blood cells of the lymphocyte subtype. They function in the humoral immunity, or commonly known as body fluids, and they are adaptive immune system by secreting antibodies. So what can hinder this immune system we just talked about? One of the main things is lack of sleep. During sleep, our immune system releases certain cytokines which increase with infection or inflammation, or during periods of stress to combat illness. If the body is deprived of sleep, it may actually decrease production of these protective cytokines and infection-fighting antibodies. Cytokines play a main role in the innate immune response by means of direct mechanism against invading agents, inhibiting viral replication, or by activating mechanisms for cells such as NK cells, macrophages, which upon activation produce more cytokines. Smoking is another big way to disrupt your immune system. Smokers get sick more often because the smoke paralyzes tiny-like structures in the lungs called cilia, which otherwise sweep dirt and bacteria out of your lungs. Because cells within cilia are damaged or destroyed, the secretions accumulate in the widened airways and serve as a breeding ground for bacteria. The bacteria furthers damage on the bronchial wall, leading to a vicious cycle of infection and airway damage. Sugar. Eating or drinking too much sugar curbs immune system cells that attack bacteria. This effect can last for at least a few hours after downing a couple of sugary drinks. Sugar stimulates the production of free fatty acids in the liver. When the body digests these free fatty acids, the resulting compound that can trigger inflammatory processes. Different kinds of sugar may contribute more or less to inflammation. Alcohol alters the number and relative abundance of microbes in the gut microbiome, an extensive community of microorganisms in the intestines that aid in normal gut function. These organisms affect the maturation function of the immune system. Alcohol disrupts communication between these organisms and the intestinal immune system. Alcohol consumption also damages epithelial cells, T cells, neutrophils in the GI system, disrupting gut barrier function and facilitating leakage of microbes in the circulation. What does the immune system need to thrive? Exercise. Regular exercise can boost your immune system and help fight off infections. Exercise allows immune cells to perform effectively. It increases blood flow, reduces stress and inflammation, and can strengthen antibodies. What's important to note is 30 to 60 minutes of moderate intensity, including strength training and cardiovascular exercises, is recommended. Refrain from more than 90 minutes of high-intensity exercise, which could put too much stress on the body and begin to hinder the immune system. During sleep, breathing and muscle activity slows down, freeing up energy for the immune system to perform these critical tasks. The inflammation that happens during sleep could harm physical and mental performances if it occurred during waking hours, so the body has evolved so that these processes unfold during nightly sleep. Melatonin, a sleep-promoting hormone that is produced at night, is adept at counteracting the stress that can come from inflammation during sleep. The amount of sleep each individual needs varies. For example, adolescents need more than an average of 8 hours since they are growing. Another example would include during times of sickness or after a significant injury or surgery. Sleep is a time where the body has a chance to heal. Nutrition. Adequate and appropriate nutrition is required for all cells to function optimally, and this includes the cells in the immune system. An activated immune system further increases the demand for energy periods of infection, with greater basal energy expenditure during fever, for example. Thus, optimal nutrition for the best immunological outcomes would be nutrition which supports the functions of immune cells, allowing them to innate effect responses against pathogens, but also to resolve the response rapidly when necessary to avoid any underlying chronic inflammation. Some nutrients and delivery of components have specific roles in the development and maintenance of the effective immune system throughout the life course or in reducing chronic inflammation. For example, the amino acid arginine is essential for the generation of nitric oxide in macrophages, and the micronutrients, vitamin A and zinc regulate cell division and are also essential for successful proliferation response within the immune system. Just with that example alone, you can get a grasp on how important proper nutrition is to maintaining a healthy immune system. Vitamin C. Vitamin C helps encourage the production of white blood cells, which help protect the body against infection. Vitamin C is a very powerful antioxidant that can strengthen your body's natural defense. Antioxidants are molecules that boost the immune system. They do so by protecting cells from harmful molecules called free radicals. For adults, the recommended daily amount for vitamin C is 60 to 90 milligrams a day, and the upper limit is 2,000 milligrams a day. Although too much dietary vitamin C is unlikely to be harmful, megadoses of vitamin C supplements can cause diarrhea. Dietary sources of vitamin C: spinach, kale, bell peppers, Brussels sprouts, strawberries, papaya, just to name a few. And of course, there we have our good old oranges that have vitamin C in them as well. Vitamin C is in so many foods that most people do not need to take supplements unless the doctor advises it. Consult with your doctor before taking any vitamin C supplements. Vitamin E. Like vitamin C, vitamin E is a powerful antioxidant that can help your body fight off infection. This important vitamin, part of nearly 200 biochemical reactions in your body, is critical on how your immune system functions. The recommended daily allowance for vitamin E for males and females ages 14 years and older is 15 milligrams a day. Plant sources for vitamin E include almonds, peanut butter, sunflower seeds, oils such as sunflower, safflower oil, and soybean oil, hazelnuts, and avocado. Vitamin A. Vitamin A is an infection fighter and comes in two forms: preformed, such as in animal foods like fish, meat and dairy, or from plants called carotenoids. The recommended daily allowance for men and women is 900 to 700 micrograms. The tolerable limit for adults is up to 3,000 micrograms. Be careful with vitamin A toxicity. When it comes to carotenoids, plant-based versions of vitamin A that you could get would be from carrots, sweet potatoes, pumpkins, butternut squash, cantaloupe, and dark leafy green vegetables. Vitamin D, known as the sunshine vitamin, it is one of the most important and powerful nutrients for supporting the immune system. To reap the benefits of self-production vitamin D, spend 20 to 30 minutes in the sun. There are two main forms of vitamin D. There's vitamin D2 and vitamin D3. Vitamin D2 is found in plant foods like mushrooms, and vitamin D3 is found in animal foods such as salmon, cod, and egg yolks. However, sunlight is the best natural source of vitamin D3. The UV rays from sunlight convert cholesterol into your skin into vitamin D3. If you're going to take supplements, after discussing it with your doctor, the RDA for vitamin D is 600 international units per day for young adults and 800 international units per day for older adults. Food sources for vitamin D include mushrooms, salmon, mackerel, tuna, sardines, vitamin D fortified milk, orange juice, and cereals. A fun fact about mushrooms, mushrooms can actually regenerate even more vitamin D and left out in the sun for 30 minutes even after being picked. Folate or folic acid. Folate is a natural form, and folic acid is a synthetic form, often added to foods because of its health benefits. To get more folate, add more beans, lentils on your plate on a regular basis, as well as leafy green vegetables. Avocado is another tasty source. Folic acid produces an increase in T cell distribution, and the daily amount for it is about 400 micrograms. Iron. Iron, which helps your body carry oxygen to cells, play a part in many of the immune system processes. It comes in different forms. Your body can more easily absorb heme iron, which comes from animal products. Iron is best absorbed with vitamin C. Be careful to take away from calcium foods or supplements as it can interfere with iron absorption. The recommended daily allowance for all age groups of men and postmenopausal women is 8 milligrams a day. For premenopausal women, it's 18 milligrams a day. Plant sources of iron include beans, broccoli, kale, and iron-fortified cereals. Selenium. Selenium seems to have a powerful effect on the immune system, being important for preventing infections. Animal foods are the best source, with that exception of Brazil nuts that have a whopping greater than 100% daily value in one nut. However, too much can be a problem, so be aware of your intake. The RDA for adult men and women 19 years or older is 55 micrograms a day. Zinc. Zinc is needed for the production of the new immune cells. It can be found primarily in animal food, but can also be found in some vegetarian food like baked beans, yogurt, and chickpeas. The recommended daily amount of zinc is 8 milligrams for women and 11 milligrams for adult men. Protein. Protein is an important resource for enhancing the immunity because it helps form the cells that operate the immune system. The amino acids that are found in protein form the building blocks of all the body's cells, including the cells that power your immune system. How much protein do I need? Everyone's a little bit different depending on their activity. 1 pound is equal to 0.45 kilograms. So for example, I weigh 160 pounds, which is equal to about 72 kilograms. I run and lift weights about 4 to 5 times a week. Therefore, I would multiply 72 times around 1.5, and that would give me 108 grams of protein. For the average sedentary adult weighing 130 pounds, their protein intake should be around 46 to 50 grams per day. It's best to limit each meal to no more than 30 grams, as your body can only metabolize so much protein at once. So in review, the immune system is very complex, but easy lifestyle changes such as sleep, exercise, and proper nutrition can help support it. And always remember that a healthy nutrition gives the immune system the proper fuel and tools to power the dynamic role players in warding off bacteria, viruses, and long-term diseases. Thank you for watching this presentation on the immune system. I hope it helps, and if you have any questions, you can go ahead and email me.